3.5 is transformations of exponential functions. This is all stuff we've done. We've dealt with the a value, the k value, the d value, the c value. All these things are things we've already done. We just have a new base function, y equals b to the x. So I'm just going to write that here. This is our new parent function, base function, whatever you want to call it. Y equals b to the x. And we have all these attachments to y equals b to the x that change the look of the graph. Okay, so I'll go over again what these things represent. They represent the same things as they always have. So our a value over here, this is our vertical stretch or compression. Okay. This a value, if it's negative, also tells us if it's a reflection in the x-axis. And this is if negative. Okay, so if this a value is greater than 1, we have a vertical stretch. If it's a less than 1, between 0 and 1, that means it's a vertical compression. Okay, so this language is really important to be able to come up with. Okay, we're going to move on to our k value next because these are both multiples. So our k value, this is similar to the a value, except this is a horizontal stretch or compression. Of 1 over k. Okay, so a little trickier than the a value. We have to first find the reciprocal of k and then consider whether it's a stretch or a compression. So if it's a 2, really you have to consider a 1 over 2. 1 over 2 is less than 1, therefore it's a compression. Okay, this also tells us if it's a reflection in the y-axis. So if this k value is negative, we have a reflection in the y-axis, so it flips horizontally. Remember, all this stuff that is inside the function, k and d, always have to do with the x values. Okay, so when we say a reflection in the y-axis, all the x values go from negative to positive or vice versa. Okay, next is the d value. The d value is our horizontal translation. Okay, so this d value just tells us if the function is moving left and right. We call that translating. Nothing is happening to the function, it's just moving left and right. Okay, and remember, it's always going to be opposite because the formula is x minus d. So in this case right here, d is actually positive, even though there's a negative sign in front of it, because the formula has a negative sign. If this were a positive sign, you have to think, to get a positive sign, I must have plugged in a negative d value, and a negative d value moves the function to the left. Okay, lastly, D and C are the easy ones. My C value is our vertical translation. Okay, this is really straightforward. It's whatever sign this takes is the direction you're going. If it's positive 4, you go up 4 units. If it's a negative 4, you go down 4 units. This is a vertical translation, however many units it says there. Okay, so all these transformations can be attached in any combination, right? It could just be a b to the x, it could be b to the kx, it could be a b to the x plus c. Any combination can happen, and you need to understand what each letter means when you have those combinations. Okay, so now let's put one to the test. We're going to graph an exponential function that has every letter involved. Okay, except I don't have an a value, I just have a negative base. Technically the a value can be considered -1. Okay, so here, let's graph our base function, and our base function is just y equals 2 to the x. Y equals 3 to the x. So the base functions kind of change, but they're all kind of the same. Now, if I have to graph y equals 2 to the x, I can use a table of values for now. I always start at 1 on my y-intercept because anytime I plug in 0, no matter what the base is, it's going to go through 1. If this function is an integer, I know that I'm going to have exponential growth. So I know it's going to kind of look something like this, and I'm going to go up over here. Okay, this is generally how my base function looks. If I want to be more accurate, I can plug in 1 into here. I'm going to get 2. Yeah, it looks like 2. I'm going to plug in 2. 2 squared is 4. This is about 4. Yeah, it looks pretty accurate. Okay, not too bad. Okay, now, First of all, I want to show you an algebraic trick here to deal with this k value. Okay, now that k value, I don't want to deal with the k value if I don't have to. And in exponential functions, I can apply that exponent to the actual base. So instead of thinking of y equals 2 to the 2x, we could just think of y equals 4 to the x. Okay, so take a look at that for a sec. I can either apply the transformation and horizontally compress it by 1 over 2, like on the previous board, or I can just apply that exponent to the 2 and call it 4 to the x. Now this is my new base function. I don't have to deal with a horizontal compression, which is probably the most annoying part of graphing any function, really. That k value is kind of tricky. So I can graph this. Still goes through here, right? If I plug in a 1, I get 4. If I plug in a 2, I get 16. So now I'm skyrocketing here. Okay, and I'm still going across this way. It's a little inaccurate, but it's okay. Okay, or I can consider, look what I'm doing. I'm horizontally compressing. I'm taking this point and multiplying it by 1 over 2. So it goes this way, horizontally. Okay, all these points get multiplied by 1 over 2. Okay, I just prefer to do it this way. Okay, so I've changed it to 4 to the x. Next, I'm going to deal with this negative sign over here. I'm going to flip all these numbers. Okay, what I mean by flip all these numbers? Well, now it's going through negative. This is, what was it, 4? And this was like 16. Terrible scale. But it's okay. I'm going to go negative 4 and negative 16 can be down here. It'll be a little off, but it's all good. Okay, now I'm going to graph through here. This one gets flipped to the negative realm. This one gets flipped down here. And I have exponential growth just in the opposite direction. Okay, that's all that negative sign did. It reflected it in the x-axis. Okay, now the last two. The last two are going to be the 3 and the 5, the d value and the c value. I got to move 3 units to the right and 5 units up. 3 units to the right, so I'm going to take this point, 1, 2, 3, and 5 units up, which brings me up to this 4 over here. Okay, now I can do that with every point, but I really want to do that with my asymptote first, especially actually only the plus 5. I want to take my asymptote, which is at y equals 0, and place it at y equals 5 now. Okay, so I'm going to have a dotted line. I can imagine it. I always like to draw dotted lines for my asymptotes just because it helps me draw my estimation. Because I know that this is going to approach that value, and then I'm going to bring this 1, 2, 3, and then 5 up. It'll be around here somewhere. Okay, and even this 16 is going to go 3 over, 5 up, around here somewhere. Okay, so I'm doing this and this in the same step. I've horizontally compressed it from green to orange, or brown, whatever that is. I flipped it in the x-axis using that negative sign, and then I moved it over to the right and 5 units up, and I'm done. This blue function is my final answer.